Hey, what's going on? This will be the third installment of my new 3D design challenge video series, I guess, where I basically think of a problem that I don't know that I have and then try to 3D design a 3D printed solution to the problem, I guess. That's kind of weird wording, I know, I'm sorry. So if you own a 3D printer, you know that the prints take a long time, and then if they start to fail, two things: you're going to waste a ton of filament, and there's a potential that you're going to cause damage to your 3D printer. For example, 3D prints like to curl on a corner if you don't have a heated build platform, and so if it curls, and they print one layer at a time, so if it curls up, you get parts of your print that are actually higher than the current Z the current height on your z-axis that you're at, meaning the nozzle can actually come and hit that part because it's not up to that level yet. And the only reason it's up there is because it curled up there. So every time that goes by, it's going to bang into it. And I've actually lost my first nozzle that way, and MakerBot replaced it because, well, it's a pile of crap, and I had like 10 prints in a row fail, and every time it'd come by, it would bang against the part that was curled up. And so basically, if you do a long print, you have to keep an eye on it. So if you're not at home, you gotta set a webcam on it and then stream it through something like what I used to use is Justin.tv, but I think it got bought out by Twitch, or did they change their name? Either way, use a free streaming service, and then you can check it from your cell phone to see how the print's going. And if it looks like it's starting to fail, you can SSH into your computer from wherever you are and then cancel the print. So you just kill the process for the MakerBot software. So that's what I bought this for, and it works okay. It's got like this stupid little thing. It's really meant to be hung like on the top of a computer monitor, but the top of the printer is like this thick of the frame, so that it doesn't work very well. And then plus it gets in the way of the actual print head comes by and will hit it. So at this point, I have literally zero idea how I'm gonna do this. So you're basically gonna come along for the ride. I'm gonna come up with something. I don't know if I'm gonna end up detaching this whole thing because this is weighted. It's kind of heavy. I don't know if I'll detach it and then come up with my own thing to snap this into the main camera part into that snaps onto the frame. I don't know. It's gonna have to be pretty thin because the whole print head assembly. It comes pretty close to the front, which is where I would probably mount something like this. So yeah, I guess we will head to the computer, and I will just start to design and do measurements and crap, and obviously I spend quite a bit of time doing that because I suck and I'm slow. So I'm gonna speed the video footage up, probably 3 or 4x like I have in the prior videos, just so you don't get bored out of your mind watching me fiddle around because I'm not experienced. And then I'll do some test prints, and if I can remember to, I'll do time lapses of the prints because that's always cool to watch. And then if I find that it fits and it works and I'm happy with it and ready to call it quits, then I'll fire the camera back up and then show you the finished product, and then I'll show you it in action, or maybe not in action, but I'll show you that, you know, it fits and it won't hit anything and everything clears. So and even if I fail on this, I'm still going to post a video because failing is learning. So I don't like to quit though, so hopefully I don't come to that. But yeah, let's get started. Okay, so I lied. Before I get started, I thought it would be important to show you this because you might be confused as to why I'm designing what I'm designing in the manner that I would, because I took the whole thing apart because the whole unit was just huge. I mean, you just saw it a second ago, and then the entire like massive weighted assembly that hangs off the back of your monitor wasn't removable. The hinge was completely inside the unit, and I had to take the whole thing apart to get to it. And by that time, I started losing patience, and yeah, I destroyed it. So anyways, it has a little strainer leaf right here, which I can't seem to get that back on, but whatever. So this is basically the entire board stripped out of there, ready to go. So it's a lot smaller, which is good. This means that the entire print will be smaller and should print more quickly, less chance for failure, and it should make it a lot more simple. Now, I will say though that this means I'll actually have to make the project in a couple parts, and it'll have to assemble, most likely using the screws that I salvaged out of this thing when I took it apart. So the PCB will mount to the bottom of my project using the screw hole, so I'm going to have to take some really careful measurements. I'm also going to be putting the accuracy of the 3D printer to the test, because these are the ridiculously tiny little screws, so I'm going to have to make the holes really, really, really tiny. Obviously they'll self-tap and it shouldn't be a problem, but the question is, can I get a hole that tiny in my print? Because I don't know if the X and Y resolution on the printer is good enough to pull that off. I guess there's only one way to find out. I'll probably make a little test print with some holes just to make sure it works before I go wasting, you know, a couple hours printing the whole thing. But I was thinking of making a probably a bottom piece with the holes, and then I'll screw this to that, and then a top piece that'll actually have depth to it with a little hole for the viewfinder, and I guess probably for the microphones, and then it'll snap over the top, and then, well, yeah, and then the top will just screw into the bottom. I'll just have to make the walls of, or the bottom part hang over enough to where I have room for screw holes, so then I can screw the back plate onto the main enclosure box, I guess. But you'll see when I'm 3D designing this. But this is kind of blazing new territory for me, so there's a pretty good chance of me failing on this one. So I've yet to fail one of my little 3D designs I've challenged myself to build, but this could be the one where I fail. So just a heads up, if you don't want to watch a potential failure, then you might want to turn away now, but we'll see. It's pretty rectangle-ish, so it shouldn't be too bad as far as getting measurements for where the holes and stuff belong. And you know, they don't have to be perfect, but anyways, and I can confirm I did plug this in after I disassembled it, just to make sure I didn't accidentally break anything, because there were a couple times I was trying to pry it, I had something slip and then hit the PCB, but I didn't hit near any SMD parts, because as you can see, it uses some really tiny packages. But it didn't seem, seems that I got lucky. It didn't seem like I damaged anything, so it looks like it's ready to rock. So not very big, so it shouldn't take a lot of material. Hopefully it won't take too long. I just want to keep this really simple. I'm trying to think if there's any other methods, but the enclosure, that's one problem. There's another, you know, the other problem is that because you can't print overhangs, you got to print this kind of stuff in multiple pieces, and so I'm gonna have to come up with some kind of design for mounting it to the actual to the 3D printer over there, and then having the case that I'm gonna print for this will somehow attach to that, and so that'll be another little challenge, I guess. So anyways, now that you know that I'm designing the case around this and not the actual full retail package, all that crap, that'll make more sense now. So I think now we can get going with the time lapse of the design process in CAD, or well, SketchUp. So yeah, let's get started. Okay, so before I skip to all the finished stuff, I thought I'd at least discuss what I designed and why I designed it the way I did before. Yeah, you know, I just didn't want to go from silent time lapse of me designing it straight to, oh, here's the finished product. I thought while it's printing, which you could probably hear it in the background, it's pretty loud. I figured I'd describe what's going on here. So, first off, with 3D prints, I could have printed completely enclosed. You can print up to about from this bottom face up to where this part meets the top half. Pause the print, because on the printer itself there's an option to hit pause. Put the board in there, mount it to the screw holes. Actually, no, you'd want to come all the way up to here because you wouldn't want the printer head to be below anything that protrudes higher in respect to the z-axis. So when you get up to the top, before it started printing the top in, you would fit the board down into there, and then it would print this top part in. But the problem with that is if it broke or you needed to work on it, you'd have to destroy it to get to it. So I decided to do just a simple box, a top and a bottom. Bottom with some screw holes that screw into the very thick walls of the top piece, which is just a shell. And then I left a hole open right here for, so that's actually something I didn't, oh, I guess I just didn't mount it all the way back. This is supposed to go flush against the back, but the cable comes out of here, and then I figured it'd be best for the cable to come up so then it can wrap, because this right here, this top part will be hanging over the top of the printer. And so I wanted the cable to come up and then along the top of the frame around to the back where it's kind of out of the way. Because if I had it come out the bottom, it would be dangling through open air and there'd be obstructing the view of the printer even more. And so we definitely don't want that. I haven't tested it, so this design should work, but I mean it should be flexible enough that I can hang this top over, get it to fit over the top just fine. In fact, I might not even need to stretch it. I don't remember how I did the measurements of this part. And as far as the bottom, all I did was just put a little lip right here. So all I'd have to do is just slide this this middle piece in from either the right or the left. Obviously, because the cable comes out on this side, you'd probably slide it in from over here. And gravity and or friction should hold it in just fine. If not, I can put a little layer of epoxy down there and let it dry, just so it thickens it and gives a little rubbery surface to get friction against. But I don't think it'll be a problem. These are the holes that the PCB mounts to this bottom plate with. So I already did the print once. I'll show you in a second after I stopped doing the screen capture right here. I'll show you. I already printed the bottom plate once and it wasn't right. The screw holes weren't aligned perfectly. They were a hair off. These two at the top are too high by about 1 millimeter, and then the bottom ones are too low, about 1 millimeter. So I brought them both inward more, and then I think it was, I don't remember which set, but one of the sets they were actually off in the x-axis by I don't know, like 1 or 2 millimeters on one side. Oh no, the holes are too small, and you'll get to see that in a second also, because I actually kept the failed print, so I can show you the holes at the original size, which I think was it 1? I think it was 1 millimeter diameter. These are 1.5 mil. The original ones are 1 millimeter diameter, and the printer resolution in X and Y isn't as good as it is with its Z. So it actually almost wasn't even a hole. You could tell that where it went around in a circle, but there wasn't much of a gap, and I couldn't get the screw into it. So I remade them as 1.5 millimeter diameter, and I think it's about perfect. I actually got it reprinted after I did that. I didn't bother recording because the designing is really the important part. Adjusting the holes is, I mean, that's pointless. All I did is delete the holes and then just moved them. So I didn't bother recording it. But anyways, after I did that, I reprinted it. Took the PCB, screwed it onto there, and it fit brilliantly. So now I'm printing this top piece. That's actually what's printing. And when I actually go over there to the workbench to show you the first bottom plate that didn't work and show you that the holes were too small, while we're over there, I can show you the printer in action, because I don't think I've ever showed the printer while it's printing, other than the time lapse. So it's a really simple design. I don't think I have this centered in there. Yeah, I don't. But anyways, this should be perfectly centered. There's speakers on either side, but whenever I stream this, obviously anyone in the world can watch the stream if I use a public streaming service. So I think it's kind of creepy to leave the microphones on. So in the actual streaming software, I'll just have the microphones turned off. So I'm not ever going to use the microphones, which is why I didn't make a hole on either side for sound to get through for the mics. Plus, it makes it more simple. So since I did insets for the bottom screws on the bottom plate, this is the top half on the print bed, and then the half of this that's touching the top was on the printer bed. And as far as this one, this up here where the hole is was the surface on the print bed. Actually, it is right now. It's still printing. Because if you remember from me mentioning it in prior videos, if you're 3D printing, you can't have overhangs. So you can't print something in midair. It has to be against a flat object, or you have to print straight up for more printed filament. Which means that this mount piece, I'm going to have to print it like this, flat on the bed. That way, whoops. And this, I have to print it like this, where this would be the top, and then these would obviously all be the sides. And that way it prints straight up. That way there are no overhangs. So that's kind of how I overcame the whole no overhangs deal, is just printing it in 3 parts. Mount the PCB to the back plate, mount the back plate into the front plate, and then slide it into the mount assembly, hang it over the edge of the printer, and it should be good. Now I don't know if I need to put like foam, like adhesive foam at the top, or if I need to make another thing that comes inward right here as like a lip. I think this should hold just fine. I think I gave 1 millimeter of extra wiggle room in each direction, but I think this should fit just perfectly enough that I don't think I would need anything else. I think I should just be able to dangle this over the edge, and then it'll be perfectly fine. And this is only it's only 4 millimeters, so surely 4 millimeters into the front build area shouldn't ever hit anything. I imagine they gave a little more wiggle room than that as far as where the extruder head moves around. If not, I can always adjust it to be thinner or whatever, and maybe not come down so far, because technically the lip doesn't have to come down that far. That's overkill. Oh, and just to make it look a little nicer, I didn't have to, but I decided to round this corner, that corner, and that corner. Now, as far as the unit, I didn't bother rounding all of these because I was going to have the screw holes and stuff there, and I just thought making it regular and square would save time as far as printing, because I think printing curves probably, well, actually printing curves might be faster now that I think about it, because the slicing software or algorithm has some stuff in there for acceleration, because obviously you don't want your extruder head to go from full speed, like full travel speed, to just stop, coming to a dead stop without some sort of smooth deceleration in there, because you could end up with skipped steps and stuff. And plus, it'll shake your whole printer, and it could cause your chassis to flex and your print quality to go down. So they have algorithms in there that'll do deceleration, or actually it's just acceleration. So because of that, I think coming around a corner would allow it not to have to slow down as much, so maybe printing curves would actually be quicker. Don't know, don't really care that much. Just curious to see if I can get this one accomplished. This one's a little... The bottom plate turned out decent. It took me 2 prints, obviously. 1 print and then an adjustment and then a reprint. So I'm already off to a kind of a shaky start, but top piece is being printed right now. I don't think there'll be any problems with it. I mean, it's a pretty simple piece. All it is just a half box with a hole cut out here for the wire, a hole in the bottom cut out for where the lens protrudes. I designed it to where it protrudes through just a tiny bit. Now this is protruding more than it should because, as you can see, the PCB isn't flush against the back. But I didn't want it so far inset that the outside of the shell would be in the field of view of the camera, because that's obviously not what you would want. So will this turn out? I have no idea, but let's go over to the bench and then I'll show you that failed bottom plate. And then we can also take a quick peek at the printer while it's printing this. I think it's about halfway through, so this should be something to look at. Okay, so the printer, when it's doing the infill and stuff, it's vibrating back and forth really quickly, and it's shaking the whole bench. And with using the tripod, it was making the image in the camera. Well, actually, it's my phone, but it's making the image in the viewfinder really fuzzy. So, anyways, here's the successful one. As you can see, it didn't turn out too bad. You can see the insets for the screw holes. These are the screw holes for mounting the PCB, and as you can see, I have the screws in there, and it worked brilliantly. It fit right in there. So now I am printing the top. So as you can see, that is a printer in action. Okay, so not very exciting. Here's the first failed one, and as you can see, those holes are a wee bit tiny. It's not, I don't know if it's necessarily a printer's fault. I think I just made the holes a hair too small, so I just made them 50% bigger for this one, and it worked just fine. So, oh, no, that's another thing too. You can see this part looks like it messed up a little bit. It did. I had a little bit of, not, what would you call it? It's kind of like an open face. I just had a little single line just pointing out into the air. And so it technically has no dimension or depth to it, and it kind of screws up whenever the slicing software goes to slice it into G-code. So I went and cleaned that up, so when I printed it the second time around, it was perfectly fine. But I did use a raft, because if you don't use a raft with this shitty printer, because it didn't come with a heated bed, despite me paying $2,300 for it, you think for that much it would come with one, it curls. The edges curl as it cools off, so I basically have to use raft. The bad thing about using a raft that sucks is that you don't get a really smooth side. When you print straight onto the build platform without a raft, the side touching the build platform ends up being really, really, really smooth, and it looks really nice. Obviously, when you use a raft, you don't get that. You end up getting a little bit of texture to it, but I think this is actually the side that was touching the raft. As you can see, it's pretty textured. But, what can you do? But that's the failed one. So, but it's not a lot of material. I use 100% infill for that. For the top shell that's printing right now, I think I set it to 90% infill. Now, what angers me, MakerBot never ceases to piss me off in different ways. I loaded a part up and then realized that I needed to adjust the screw holes for the top piece because I made them all the same size. So I closed the software, went back to my main workstation, adjusted the actual STL file, re-exported it, reopened the MakerBot software, and when I had closed it, when you close it, it automatically starts an update process. You don't have any way to opt out of it or hit no or cancel it. And when I went back in, I noticed I added a ton of like advanced settings. So whenever you go to print, now there are probably 3 or 4 times as many settings you can change, which is, technically speaking, that's awesome that you get more flexibility now, kind of like the third-party, like open source stuff. The downside is that I already had all the settings perfect for this, and now that I got the new version, I don't know if the other settings that it added, if those defaults are the same as I was using with the prior version. So, it might, because I set everything else to match the settings I used to print this, but on this new thing, the raft kept failing, and the edges were curling up really, really, really badly, where it didn't on the prior version that I used, like an hour ago. So, it's MakerBot. Shitty design. Why would you force the user to update? Updates are good for security fixes and stuff, but sometimes if you have a working version, especially in a production environment, you don't want to upgrade because you risk introducing a bug or a problem. In this case, I had a perfect settings template for printing that I had down, especially for my specific filament, and then they go and update the software, and now I don't know if the advanced settings defaults are the same as what the prior version used or not. So I guess I'll never know. We'll really know when the print finishes. We'll see if it turns out okay, but the raft is having problems, so I don't know. We'll see. looks like the raft curled enough that it actually made the the top piece I had to print upside down. Either that or the whole top would end up being an overhang, and the inside would be all support material. So I printed it upside down, and so the raft was curling. I don't have any raft in here to show you, but the raft started to curl on the edge, so it even made the print curl. So the top of it, one corner is going to be curl a little bit, which pisses me off. But I didn't want to waste the filament and start it over. It'll be on the side that faces in towards the 3D printer, so technically people wouldn't ever see it. It just bugs me that it didn't turn out the way it should because the printer's a piece of shit. I guess I can find out what it costs to upgrade to a heated build platform, but I really, really, really do not want to give MakerBot any more of my money. I despise the company, as most people do, for good reason. And since Stratasys owns them, and they're not doing anything to make the situation better, fuck them too. Sorry, I get a little angry when it comes to MakerBot. But anyways, so far so good. As soon as the top finishes, I'll probably fire the camera back up. We'll take a look at that, and then I'll print the mount, and then we'll do a test fit on the printer, and then see how it turns out. And if anything doesn't turn out, I guess it'll be back to the drawing board. Ta-da! It's done! Look at that. It fits brilliantly. So, let's take a look. Alright, so the first thing I had to do, since what you saw last, was print this top half. Because we already had printed the back plate, and I had to print it a second time because the holes for mounting the PCB were slightly off. And then I had to increase the size of the holes as well. Reprinted, and that works fine, and it was mounted. And then I had to print the top part. Well, the stupid printer is a pile of crap for being $2,300. It absolutely should not have been shipped without a heated build platform. Unfortunately, I'm stuck with this warped piece of shit acrylic. So I get curling. I printed it with a raft, which is supposed to help, but it didn't help. It still curled on this corner, and then it's actually curled over there too. I don't know if you can kind of see its convexness. You can definitely see it on this side. And the bottom plate is warped too, and so they're both warped in opposite directions because this was against the build platform, and then that side was too, and it's a pain. But it's good enough. It works. As far as assembling the things together, this is the first project I've ever done with a 3D design where I actually had parts that I assembled with a screw, where I screwed together. But you can see, even with the inset, I mean, it just worked out perfectly, and couldn't be happier with that. Yeah, ignore the warping. Barring the warping, it's perfect. But yeah, I screwed right together. The holes are big enough now that I can get the screws in, and they self-tap. But they're also snug enough that I know this isn't just going to fall apart. And then I actually had to print the bracket twice. Oh, first off, the first design, this was straight up and down, but then that meant the camera was facing straight inwards, and that means, see, with this printer, X, Y, both directions moves the gantry, but Z axis, sorry, I can't get this stupid thing to focus. But Z axis, the printer bed actually moves. So when the print starts, the bed's up here and it's fine, and you would be able to see it in view. But if you have a print that's taller than about this, as soon as the print gets like halfway down, you wouldn't be able to see it in the camera view anymore. So I decided to angle it, and the angle I came up with is 20 degrees. So this is the first print I did. If you look at it, you can tell that the quality is super, super, super good. I mean, as much as I hate MakerBot, I have to say that when it prints correctly, this thing actually does put out some really, really good prints. And anyways, the fitment is perfect also. Check this out. Sorry, my lighting is glaring and it's hard to see. So you fit it over, and then this bottom part just barely clears. And look at that. Anyways, this one, it's kind of partially due to how 3D printers work, but they don't do inside 90-degree angles very well. In fact, they kind of suck at them. And so instead of making a sharp 90-degree angle, they kind of do a rounded corner. And that means that even if you measure this perfectly, your outside corners are sharper than the inside ones. So whenever you try to fit something like this through it, which has nice sharp outside corners, it won't fit. It was way too snug. I forced it. I tried hammering it in. It just was not going to work, which is why there's some battle wounds on here that you can see. But I trust me, I couldn't force it. This wouldn't. I got it in to where it was inside of there, but this lip wasn't around the front face, and I'm a little too much of a perfectionist to let that be good enough. So that's why I had to reprint this thing, and it was an 1 and 7-minute print time, so that was a lot of wasted time. But anyways, when I reprinted it, I printed a little hair too big. You could probably see a gap in there, and then in the back too. I had to cut a piece of foam and put it back there so then it fits snug. But now that I got the foam in there, it works brilliantly. So the camera's actually on right now. I'll show you what it can see once we hook it up here. So anyways, the cable comes out the top, just like I had designed in SketchUp. So now we'll mount it. And that's just about centered. Obviously they have a centered bolt, so I can't get it perfectly centered unless I redesign it, but it's close enough. So it's aiming down at a 20-degree angle. And what I'm going to do with this guy, I'm going to actually run it up underneath here, and then there are, see, I can feel a wire right here. There are wires up here for the different motors and stuff that go from the control board. And every so often there's a little like cable tie thing. So I'm going to sneak this wire into there, and then I'll run it all the way out the back, and you won't even see the cable for it. So I think that's actually going to end up being really clean. And actually, I probably should have done that before I recorded this, but then I wouldn't have been able to pull it off the frame to show you the finished product. But anyways, it's aimed down, but the thing is, to be able to get a good view of the top of the print starting and the finish, it's not a wide enough angle to have pulled that off. So I kind of went with a compromise. So he gets everything to about where the bottom of my thumb is, like from the extruder all the way down to about here. So I'll give you an example. We'll put this on here, and then let's look at the camera. So yeah, so it gets down to like, as you can see the top of my knuckles. Now I'm going to move the camera back over to here. So as you can see, like it gets to like there. And the only time that would become a limitation is if you printed something that was literally almost 100% maxing out the z-axis, like build height or build limit, I guess. So I decided that that's close enough. I could have maybe angled it down another 5 degrees, then 25, maybe 30-degree angle, but then I risk it not being able to catch the top half of the print. So I decided it's a lot more likely, well, I mean, every print starts up here, so I absolutely have to see this, but it's very unlikely I would ever have a print that's so tall that it would ever get down to here. So I decided this is perfect. So if anyone has this stupid shitty MakerBot printer and they have a Logitech, I think it's the C920, and you want to print this and use it the same way I have, just shoot me a message and I'll upload the files. And I did adjust actually, so this will fit more perfectly without having to use foam or anything, but I didn't want to print it a third time. And if you have a better printing printer than I do, then you shouldn't have all these print quality issues. But I must say, the bracket, that part does look really great. So I guess that's it. It wasn't a failure like I thought, but I did fail on 2 of the parts and have to reprint them. So I guess it was a total of 5 prints. I had to print this twice, and I had to print this twice, and technically the main body of this, I probably should have reprinted it, but since the ugly part is facing into the printer, so nobody would actually ever see it, I decided to let it slide. So, plus it saves me time. I've blabbered on for long enough. I will see you in the next video. Bye.